That was a school bell. So now I'm going to do 1 divided by 0, and you can't divide by 0, so that is going to be undefined. So if we go back over here and we look at the tangent graph that I put on the paper for you, here is my angle axis, and this is my ordered pair axis. And this time we're not graphing the x part or the y part, we're graphing the ratio of y over x. So using my table, at an angle of 0, I'm at 0. At an angle of pi over 6, and if you think here's pi over 2, well in the first quadrant you have pi over 6, pi over 4, pi over 3. At an angle of pi over 6 you're at 0.6, so right there. And at pi over 4 you're at 1. And at pi over 3 you're at 1.7. And then at pi over 2, you're undefined. Well, when something on a graph is undefined, it's either a whole or an asymptote. And in this case, it's going to be an asymptote. And so if you think for a second, well, Guidry, I only have half my graph right now. I only have that piece. Well, if you go down here to the unit circle, you know that these three ordered pairs, are going to repeat themselves. The only thing that changes down here isn't really the ordered pairs, but instead of up here where it was a positive and a positive, down here it's going to be a positive and a negative. A negative divided by a positive in all of these cases makes all of these answers become negative. So when you go back the other way, it's going to be at negative pi over 6, you're going to be at negative 0.6. And at negative pi over 4, you're at negative 1. And at negative pi over 3, you're at negative 1.7. And then you have your other asymptote. So there's your graph. And then this length here, from negative pi over 2 to pi over 2, is a length of pi. So this length right here is a length of pi. So you're going to pick this graph up, and then you're going to paste it back down again. And pick it up and paste it, and pick it up and paste it, which makes the whole graph. So if you go down here, we talk about the parent function. You probably want to rewrite this so you remember to pull it out, but rewrite A tangent B parenthesis x minus c plus d. The intercepts of my parent function happen at 0, and then they happen at pi, and then they happen at 2 pi. So my intercepts happen every pi n comma 0, where n is an integer and it can be 0. So if I plug in 0 for n, 0 times pi is 0, and 1 times pi would get me my 1 pi, and 2 times pi gets me my 2 pi, and so on. The domain. The domain for tangent is different than the sine and cosine graph because there are things where there are asymptotes. So like I can never be negative pi over 2, and I can never be pi over 2, and I can never be 3 pi over 2. So x cannot equal, cross that off, let's try again. X cannot equal pi over 2. And then, like I just said a couple minutes ago, tangent's period is pi, so we're going to do plus or minus pi n, because I'm going to have an asymptote every pi units away from my first asymptote. The range now is negative infinity to infinity because the graph is going to go up and down forever. Halfway in between the two asymptotes, you will all have an intercept, and up here, where this is the domain, that actually is the equation of the asymptotes, where you put an equal sign instead. The amplitude is undefined because it goes up and down forever. Go back to Edmodo, and after you try the next page by yourself, you can go check the answers. The answer key will be as a picture in the completed class notes folder.